Like I said, we would apply the formulas that I defined before on our mini project Frisbee. We have a review of the EVM parameters that we already obtained before. We look at schedule and cost variances. We look at schedule and cost performance indices. And we look at estimates at completion. This was our project, how we left it in the previous section. Here we see again the earned value curve, the planned value curve, and the actual cost, and we are at period 7. You can from this calculate the cost and the schedule variances if n represent them in a graph. If you want to do that, you can stop the presentation now and calculate the schedule and the cost variances for project Frisbee over all the periods and specifically for period 7. And then we have a look at your solution. You finished your calculations? A great job. In the table we find the schedule and the cost variances. The cost variance is represented in the red curve and the schedule variance in the blue curve. And we see for period 2 we had a short revival of the project. We were a little bit ahead of schedule, but afterwards the schedule variance went further down, and the same for the cost variance. Not very difficult to calculate, it's just the differences that we defined before. If you want now, you can stop the presentation and calculate the schedule and cost performance indices. Now we can calculate the schedule and cost performance indices for our project Frisbee, and we find the different parameters in the table. For period 4, for example, we find the SPI, which is earned value divided by the cost baseline, which is approximately 0.9. We find the CPI, which is earned value divided by actual cost, and the CSI is the product of 0.9 and 0.8. You will see that these values are not exactly correct because I rounded them. When you would go to Excel and you put more decimals, you will see a more exact value. Those parameters are presented in the graph, and we see the SPI in blue, how it evolves over time, the CPI in red, and the CSI in orange. From this, you can use the parameters to calculate the estimates at completion. Like before, you can stop the presentation, do those calculations in Excel, and then start with the presentation again. When we look at the estimates at completion, we use the different formulas to calculate them. So we can find the mathematical estimate, which is shown in the blue curve. We can find the estimate with the CPI, which is in the orange curve, and we have the red curve representing the estimate at completion with the CSI. We also have the green curve, which gives you the budget at completion, which of course is a constant. And we see for most of the time that the estimate at completion, the mathematical estimate, is the optimistic value, the CPI-based value is the probable, and the CSI-based value is the pessimistic. You can, for every period or at every period, see what your estimate at completion can be. This gives you information about the performance of the project, and you can use this to evaluate your project. Do I have to continue or do I have to kill the project? When those estimates are too far away from your values estimated in the business case, it may be a good reason to stop the project and to avoid further losses of money. A lot of calculations in this session, but I'm sure that you got through this very well, and I'm looking forward to see you in our next sessions. Have a nice day, and I will see you later.